How's the first week been going for everyone here? Very quick, very easy. Life's going to be simple, barely any work to do, right? You guys are all caught up. Everything's been read, already turned the homework in. Is that how it's going? Looks confident out there. Lots of shifty eyes looking away from me. That's all right, right? So that's why we have the weekend. Got a little bit of time to kind of catch up on things here. I know I share this with kind of my advisees and my, the students that I mentor and things like that, but for those of you who are freshmen in here, right, statistically speaking, your GPA at the end of your first semester is very close to what your GPA is going to be when you guys graduate, right? You know why that is? It's because now is when you guys are setting your habits for the rest of the semester, right, and the rest of your time here, right? So if you guys are feeling a little bit overwhelmed, a little bit behind, maybe take a little bit of time there to figure out how we can be a little bit more efficient with the work that we are doing, right? And I'm always here to help you guys out, even with that kind of stuff, right? I know I'm teaching you guys chemistry, but it wasn't all that long ago where I was a student too. So if you're struggling with some of these things, just come and talk to one of us or any professor that you want. I think I shared with you the secrets of being a professor, right? I can't remember if it was this class or not. But us professors love to hear ourselves talk all the time, right? So just come ask us a question. We'll talk your ear off. Sound good? I'm like, no, I don't want. Okay, I hear enough of you. Already an hour a day, right? But anyway, so we've been making our way through chapter 1. We're going to finish that up today and move on into chapter 2. One of the big things that we started to introduce, and we'll just kind of recap a little bit more today, is this idea of dimensional analysis, right? We talked about the metric system, how we can convert between different units of measure from the big to the small, right? We talked about the SI units that we have for different types of measurements, right? Celsius and Kelvin for temperature, kilograms for mass, and all these other kind of things through there, right? So we're going to have a couple of different problems that we work through as we go through today, but this is going to be one of these recurring tools that you guys are going to need to be comfortable with as we go through the rest of this semester, right? Converting between different scales of measurement. How can we convert from milligrams into kilograms, or kilograms into centigrams, right? All these kind of things along the way there, right? And then we also talked a little bit about density, and we did a couple examples of how to use density and what the relationship is between mass and volume, and how to convert units and set up our math so that we can convert units appropriately too. Okay, so pretty important lecture, the last one we had there. Okay, so we're just going to keep kind of working through these things. We're going to have a couple more definitions along the way. And then we're going to launch into chapter 2, where we're dealing with atoms themselves, right? So how can we start to look at an atom and what makes up an atom, that kind of thing, all right? Okie dokie. So, let's see. I think you guys are all done with lab for the week, right? Has everyone had lab already? So you guys got all that stuff set up, right? The online system, you guys found the website, or excuse me, the Canvas site for lab, and you guys are all squared away with that, yeah? Good? Cool, okay. So any questions then before we launch on into it? All right, 100%. Everybody knows everything from previous in this week. Sounds good. Okay, let's get started with some prayer, and then we'll get going into this. And Lord, we just thank you for another day, and we just thank you for another opportunity that we can learn something from you and learn something about you, Lord. Just pray that you open our eyes just to see how the things that you have us here, the things that you have us working on, all point back to you in whatever way that might be, Lord. We know you are the creator, and we know that you created all things. And we just thank you, Lord, that you've given us the ability and the desire just to seek after those things where we can learn about you. So we pray that you just open our hearts, open our minds, and open our spirits just to see whatever it is that you would have us be seeing today, and whatever tasks and challenges you set before us. We just pray for your strength and your wisdom in these things, Lord. And we ask all this in your name. Amen. All right, so these are the 2 practice problems. Hopefully everyone kind of has worked through these and gotten their answers and remembers kind of how we walk through them in class there, right? All right, so a little bit of turning back our attention a little bit to temperature here. Temperature is going to be another thing that we talk a lot about. I believe it is chapter 5 where we talk about thermodynamics, right? Now, we'll talk about it then, right? But thermodynamics obviously implies there's something to deal with temperature in there, right? Right? That's what the prefix there, thermo, kind of means for us, okay? So we're going to be spending a lot of time calculating how temperature moves within substances or reactions, okay? So we're going to have to know the different units of measurement for temperature. Now we talked about Fahrenheit, and that's one that we're familiar with here in the United States, right? We talked a little bit about how Celsius is going to be mostly what we're going to be talking about when we deal with temperature. However, if you remember back on the previous slide, we also talked about Kelvin, okay? And Kelvin is kind of the, let's say if you're working with physics, right? You're going to be pretty much exclusively talking about things in Kelvin there, and there's some reasons for that, which we talked about here on the slides, okay? I believe we already filled in the blanks that you guys have on the slide, but just for emphasis sake, right? What temperature does water freeze at? What temperature does water boil at in Celsius? Remember, these are one of these things that you guys should know, right? Just kind of general knowledge for how to get through this class, right? Know that water freezes at 0 degrees Celsius, right? Know that water boils at 100 degrees Celsius. Although if you remember, we talked about how elevation can change that, right? We talked about what happens if you're up at in Denver, Colorado at a higher altitude, and how that changes the boiling point of water, or how it changes the boiling point of anything, actually, we should say, right? So we're going to figure out how to calculate those kind of things. The density of water at 25 degrees Celsius, that's kind of our assumption that we're going to use that it's 1 gram per milliliter, okay? That's a very important kind of bit of information to know there, okay? The density of water, let's say at 25 degrees Celsius, is 1 gram per milliliter. Why do we typically pick 25 degrees Celsius? Well, that's right around room temperature, okay? So that's just one of these standard measurements that you guys will see over and over and over again. And when we talk about these example problems, once we've defined kind of how to calculate temperature and things, I'm going to have to specify whether we're at 25 and what standard temperature and all these other kind of things that go with it, okay? But it's just one of these assumptions that we make that we're at room temperature, and that's typically what we quote, right? So we'll talk a little bit more about that though. Kelvin's the SI unit. It's based on the properties of gases. The real thing why we need Kelvin is because there are no negative values for Kelvin, okay? We can get a 0 for Kelvin. That's all the way down there at absolute 0. I'm sure you guys have probably heard the term absolute 0 maybe in some kind of movie or maybe reading through some kind of textbook or something like that, right? The idea of absolute 0, okay? But it's important, right, that we don't have negatives, and it's important that we can't practically get to 0, right? 0 Kelvin is something that we can reach theoretically, okay, but really in reality, we can't really get there. There's always going to be some kind of energy around. And the reason why is because we'll see some equations where we divide by a measure of temperature. Okay, what happens if we try to divide by 0? You can't, right? So if we're trying to measure things and do some calculations in Celsius, and we're at the freezing point of water, right? We can't do that math using Celsius because we'd be dividing by 0, and that's just not how it works, okay? So there's some mathematical reasons why we need to use Kelvin. The absence of negatives and the practical absence of a 0, okay? And so just when we get to the idea of gases, we're going to be dealing with Kelvin pretty much exclusively in that chapter. And I believe that's chapter 10 where we get into that, okay? Sound good? Oh, that's how we calculate Kelvin down there. So take your degree Celsius and add 273 to it.
Can you say that standard density of water again one more time?
1 gram per milliliter. Let me just go ahead and fill that in. Just so we have it here. So that's 0 degrees Celsius, 100 degrees Celsius, right? And 1 gram per milliliter. Okay. Good? All right. Energy. Okay. So we've talked a little bit about energy too. Remember we talked about kinetic molecular theory, right? That's how we describe what's going on in solids, liquids, and gases. And we talked about the motion of those molecules, or the motion of the atoms themselves, right? And so at that point I asked you guys, okay, where have we heard the term kinetic before? And we came to the, let's say the assessment that we've all talked about kinetic energy, okay? And so kinetic energy is kind of the things that you guys deal with in physics, right? So we're not going to talk too much about that here. In terms of how to calculate kinetic energy, right? So it's energy associated with motion of an object. Now what I want you guys to think about, or how I want you guys to draw this back to the dimension of chemistry, right? Is that we are going to be dealing a lot with the motion of atoms and molecules. And I think this is now the third time I've kind of tried to express this idea to you all, okay? If you look at your desk every person who's had enough coffee this morning would say it is not moving, right? It is just stationary, it's sitting there. Is that fair to say? Sure, right? But the point that we have to think about is that the atoms inside your desk are moving around. And that's what kinetic energy is for us, right? It's the motion of those atoms. Okay, that's kinetic molecular theory. Got it? We're going to be able to calculate the motion of those. We're going to be able to use the motion to do certain reactions and those kind of things. So when I talk to you guys about kinetic energy, all I need you guys to think about is, hey, things are moving around. Okay? Potential energy for us. Again, we could draw back this the lessons that you guys probably learned in physics, right? And potential energy is stored energy, right? If I hold my mug of tea here in my hand, there's a lot of potential energy right there, right? If I released it, it would convert into kinetic energy, and then one of you guys would have to clean it up, right? Okay, you didn't say no. You're like, yeah, that's pretty nice of you guys. I appreciate that. Right? You guys get what I mean, though? That's potential energy in the way that we contextualize it. In the chemistry world, what we think of with potential energy is energy within bonds or molecules themselves. Okay? What we're going to talk about is what happens when you make or break bonds. There's energy that's released when you break bonds. Did you guys know that? You sure did, right? Have you guys ever lit something on fire? Yeah, right? Does it give off energy? Yeah, fire hot, remember, one of those important things, okay? Where's that energy coming from? Well, it's coming from the breaking and the making of bonds, okay? And so we're going to be able to calculate the potential energy in a bond, right? How much energy does it take to break a bond? How much energy is released when we make a bond, okay? So potential energy for us is the energy that's stored within the bonds themselves. But before we get to all that, we're going to have to build the molecules first, and then we can break them apart, okay? So much like Legos, before we can wreck them, right, we have to build them up first. Sound good? All right. So thermal energy, right, this is just another measurement of temperature, right? Some of you guys hear the book talk about thermal energy. If I refer to thermal energy, we just measure that with temperature, right? So that's just another thought with that. There are other kinds of energy. I don't want to give the impression that it's only thermal energy, right? But that's predominantly what we're going to be dealing with. That's what I'm trying to say with that, okay? All right. Now, I don't need you guys to copy this down, right? This is why I give you guys, excuse me, why I give you guys my notes, right? Because otherwise I throw a wall of text up here, okay? I don't need you guys to copy this down. What I need is just, we are going to be talking about all these different types of energy throughout this semester. And so what I'm trying to do in this first chapter is paint you guys a big picture about where we're going with this class and introduce some of these definitions along the way. Does that make sense, right? I'm just saying, hey, we're going to be talking about this later. Then we can sit there and talk about quite a bit about what it means by an endothermic process or an exothermic process and why it's a release of energy, but it's a negative and all these kind of things. So we're going to get to that explanation there. But chapter 1, I think I shared with this maybe on the first day of class or something. Chapter 1 is going to be foundational for all the rest of the time that you guys take chemistry. All the way from now, all the way through biochem, if you guys are going that far. Okay? So we're going to be calling back these definitions and ideas in here. So I don't need you guys to memorize that. I just need you guys to maybe read through it once and say, okay, I'm going to remember that term for later. At least then I can kind of have it in the back of your mind. Okay? Remember, I'm never going to ask you guys a definition on an exam, like, hey, write the textbook definition for an endothermic reaction. Okay? I could ask you to calculate the energy of an endothermic reaction. Okay? And here's dimensional analysis. This is going to be one of those fundamental, gosh, I just forgot the word that I'm trying to think of here. One of these fundamental things, that's not the word. Apparently I'm kind of drawing a blank here at the moment. Fundamental mathematical tasks. You have to do this a lot. Let me just say that, okay? Enough fancy words. We will be doing dimensional analysis a lot, okay? Converting one set of units into another. Relating different units that we measure and what information they tell us about our chemical system, okay? What I mean is this. One of the most common dimensional analysis tasks I'm going to ask you guys to do is convert a unit of mass into amount of a substance. We're going to convert grams into moles, right? And I'll show you guys how we can do that. But that is one of these fundamental steps that we have to take in chemistry, okay? Now, that just involves math, right? Converting one unit into another. That's not too bad. But the point to think about, and where chemistry kind of takes a step into the more challenging is, I need you guys to be able to do that math, but also tell me what it means if I have 2 moles of something, right? What does that mean to you chemically? What does that mean for this reaction? How can we use it in our reaction to calculate something? That's going to be the tricky part. So this is going to be the tool that we use to start to describe some of the more complex math that we have in there, okay? And we talked about conversion factors right there. Conversion factors are just how we relate different units of measurement together, okay? So when I talk to you guys about conversion factors, that's all I mean. What's the stuff that we multiply or divide by to get there, okay? All right, so again, I've talked for a whole, let's see, 15 minutes. So run a quick conversion here, see what you guys can get to. Set up your math. Remember, the key thing, and part of the way that I want you guys to practice, is how you're going to show me this answer on an exam. Right? On your exam, show me all the work that you guys do. Oh, Dr. H, I did all the work in my calculator. Well, I can't give you partial credit for that in case something goes wrong, okay? Write down your work, show me your units, and make sure you always have values of units. Excuse me, make sure you always have units with whatever value, with whatever answer you have, okay? Oh, yeah, sure. We got a problem where I'm asking us to convert between the metric units, right? Grams, liters, this kind of thing, right? And the imperial units, pounds and inches and all that kind of stuff, okay? So I have to give you guys a conversion factor for there. How can I relate pounds and grams and that kind of thing? Right, so that's the information that's given. Okay? I tell you that we have 2,000 pound car, and I want my answer in grams, right? So I start out with 2,000 pounds of something, right? I need to do a conversion and end up with grams of something. Let me just change colors here so that we can follow along maybe a little bit easier. Okay, I need to start out and I need to end up in grams. Good? So I need to get rid of pounds as a unit and convert it into grams. All right, this is just like what we did last time. So if I have pounds up here, what needs to go on the bottom? Pounds, right? Top and bottom things cancel each other out. So pounds on the bottom, the good old LB, right? And up here, we are going to convert into grams. For emphasis sake, top and bottom things will cancel out. We're left in the proper units there. Everybody with me on this? Everybody feel comfortable setting up things like this? This is about as complex as the math is going to get. I'm just being honest. Okay? The tricky part comes when you guys aren't listening to me. And you say, well, I know Dr. H told me to write down my units all the time, but I think he was talking to the person next to me, right? So I'm not going to do it. I don't have the calories to do that, right? What did I tell you guys about calories? Jolly Ranchers in the office, right? All the sugar you guys want, okay? Or if you don't want sugar, a carrot? I'll keep carrots in my house. Okay? All right? So what do we have here then? So here's our given information, right? This information here in black, right? Those are our conversion factors. That is how many pounds per, or excuse me, how many grams per pound. How many meters per centimeter, right? How many kilograms per gram, whatever way that we can relate those two values of measurement. That's what we mean by conversion factor. Fair? Okay. Do you need to memorize how many grams are in a pound? No. Do you need to know how many centigrams there are in a gram? Yes, that is something I would expect you to know. Okay? I don't care about pounds and grams. I care about how you guys can move within the metric system here. Okay? So for every, let's see, I was using blue, right? So for every 453.59 grams, I have 1 pound. Right? Everybody feel comfortable with that? All right, somebody give me the answer. I didn't write down my, for some reason I didn't write down my answer for this. So if I take 2,000 times 453, what do I get? 907,000 and 180 grams?
Yeah.
Okay. Everybody good with that? Okay. Do I really care about sig figs for you guys? Yeah, what's up?
Do you want to scientific notation?
Good question. Okay. So we don't talk about this too much in here. I think in chapter 2 I talked to you guys a little bit about scientific notation, just to give you guys an example in case you want to do it. If you want to give me the answer in scientific notation, is that going to be the same in terms of the answer as to what I've written down here? Absolutely. So your real question is, hey, Dr. H, what do you want us to put on the exam, right? Okay, what do I want you guys to put on the exam every time? There's only one thing I want, which is what? The right answer, got it? So either way is going to be correct in this case, okay? I don't care. Part of my job is to, try and figure out to make sure that you guys have the right answer there. And either way is technically correct, right? Good question, though. Very good question. Yeah?
Would it be acceptable to write the answer as 2,000 times 453.8 grams?
No, give me an actual number. If you can solve it out, solve it out. Right? In terms of your work, right? Show me this. I want to see how you got to that setup there. But complete your math, work it through. Okay? Everybody good? I think I've got some trickier stuff here for you next. Okay, this one's going to take a little bit of thought. Let's see what you guys can come up with. Work with the person next to you, or if they're asleep, work with the person to the other side of you. See what you guys can come up with for how to tackle this problem. A little bit trickier. So take a look at the slide there I have for you guys, where I gave you the different conversion factors and metric. So you can pull up any phone if you don't. I don't care if you don't use your phone in class. I'm not going to do that on that kind of stuff. Okay? So, but yeah, it's one of your dimensions for. No. So when we're dealing with milli, centi, kilo, right? One of those things.
Right, okay.
Yeah. That is the question, right? So when we're stuck on something, it's like, well, what are we even supposed to do, right? So this is why I always say, take this and turn back out what information you do, right? Obviously, I'm giving you information in centimeters and picometers, so we do have to figure out a way to list those things, right? But then we need to figure, it's not just centimeters as an arbitrary dimension, it's the diameter of a penny, right? So it's centimeters per penny, right? That I'm asking you how many amps per penny. Right, so try and think if you can break that down into different units that you need to convert it to. Does that kind of make sense?
Since I just
Yeah.
don't know what we can do it, what our answer is in terms of this, because you're asking how many atoms.
Well, that's, remember, we need to figure it out per atom, right? So we need to figure out which of our measurements is per atom. Sure, yep.
Sorry.
No, that's a good question. I'm just walking you through it. I'm not, to make sure that you understand. No, very good question. Are you going the way you like it?
Yeah.
Has it been a pain in the butt?
That's what I was gonna ask you. Do you know how you record that?
Yeah, it's posted to YouTube.
Oh, it is? Oh,
Yeah,
okay.
so if you go to Canvas, like within the modules, there's a link to the AMU chemistry channel, or if you just type in AMU chemistry, it'll bring you there too,
Okay.
and then this will be posted there.
Oh, yeah.
Also, for what it's worth, I know somebody in here is a note taker, and so if the university knows about this and you're registered, the student services, you can access the notes also.
Okay.
So it might be something to think about if you want that. Okay?
Thank you, yeah.
But you'll just have to talk to the appropriate people about just getting set up with that, which I'm sure would be fine in this case, right? It's kind of hindering, right? So, what's up? Yep. For the exams, while you're in class, I don't care about that. Yeah. So use whatever you want while you're in here. I'm not gonna, use your phone or whatever it might be. What's up? Maybe. I don't know if necessarily what you might mean by easy.
Or like a bathroom, like
Yeah.
bigger than.
Yeah, and this is kind of what I was trying to mention there with scientific notation. Like, I would much rather write something like that down than all that stuff there, because it's very easy to kind of miss a zero or not a type, right? So there are certain cases where, scientific notation is pretty much going to have to be used, right? So that might be my better answer for you in this case, right? But again, at the end of the day, it kind of is what you guys are more comfortable with at the moment. As you get more familiar with doing the calculations, right, you could maybe go use the scientific notation, but for the beginning, like, okay, I have to do it this way just to make sure I get it right. So, again, but this is the question I was out there, like, I don't care what you do, right? All righty, how we looking here? You know who? The people behind you are very serious, so don't talk to them. Look at them, they're looking suspicious also.
I don't know if we have the same numbers.
The values that you have. Yep, that looks good. Yep.
Like if we did 7.42.
Okay, just make sure you're, so this one, yeah, but, and I'm not taking on your end, just saying, just, and that's how you roll, that's how I do it, I catch my mistakes, right? It's pretty easy to do, but let's do this one. Okay, so, pull it up with your phone. Yeah, it's Pico, PICO, yeah. That would be a good place to start. Yep. A little bit off. Yeah, I can understand that, sure. So let's take a quick real quick what you wrote down. So I'm gonna ask you the obvious question you haven't already answered. Are these the same thing? No, right? So we know we have to find some way to relate these. That's what I'm gonna start with. So look up information about what's the relation between centimeters and height. And we know they're all related because of meters. Can you convert them into a unit of each other, right? That's what I would start on with. Yeah. This is 2,000. Yeah. Okay. That is 1.9. That's what that is. Yep. So, and we'll talk about, I think it's in chapter 2 where I get to this thing, right? But, so we do a lot of measurements here from really small things to really big things. We want to write out things, not all the time, right? So we do abbreviation, and that's what we have. So there was a question asked earlier about what the students about scientific notation. That's what they do. So, okay, that looks good. Okay, but now's where you go back and look at your units, right? So we know we have to relate picometers and centimeters in some way. So what do you want to cancel out and what do you want your answer to be in? That's how I would approach that. But be careful, because it's not just centimeters, right? It's centimeters per opinion, right? And it's not just picometers, it's picometers per atom. Follow how I'm relating those two there, right? Because remember, the answer is not just, right, the answer is how many atoms. But none of the things that you've written down have units of atoms in there. You see where I'm trying to make this very clear distinction here? I just be careful about how you read a certain thought. Okay? But you guys have the right idea. So I'm not saying you're, oh my gosh, everything's wrong. I'm saying just be careful about what the atoms are telling you. Or excuse me, what the question is telling you. Okay?
Could have done it in one step, but I didn't know about the other.
That's exactly how I see it. Yep, that's good. All right. So let's think here for just a minute.
Yeah.
So this is a fairly tricky question, right? Is there a lot of information given in just two very short sentences? Absolutely, right? So we need to make sure that we're reading this properly, and we need to know, or be comfortable at least, with converting different dimensions of units here, right? What's the relationship between a centimeter and a picometer there, okay? What is it from the metric conversions there that we need to know, right? Now we know they're both measurements of distance, right? They're both related in meters, but how can we convert a centimeter into a picometer? Can you convert a centimeter directly into a picometer? You can, right? If you feel comfortable doing that math. You guys following me on this? If you feel comfortable doing the math, you can convert it directly. Dr. H, I don't feel comfortable doing the math. Okay, thank you, whoever that was who spoke up, okay? So, what if you convert a centimeter into a meter? Do you guys know that conversion? Yes. Can you then convert a meter into a picometer? Yes. You guys get what I'm saying with this? If you don't feel comfortable doing it in one step, guess what you can do? 2 steps. Are you going to get to the same answer? Yeah? Or is either way going to be correct? Yeah. Got it? So let's think about this for just a minute then, okay? What's the relationship between a meter and a picometer? So for every 1 meter, we have what? 10 to the 12th picometers, right? So what does that 10 to the 12 mean? It means a 1 with 12 zeros behind it. Got it? So if you look back in your notes, I gave you guys that list here. Let me scroll back for just a second. Let's see if I can find it real quick. There it is. Okay. And we are looking right here, right? That's where a pico is. Hey, wait a minute. That says 10 to the minus 12. What is this saying? Remember, there's a difference between, there's 1,000 meters in a kilometer, right? Or there's 1,000th of a meter, right? You guys remember how we're just playing the game of inverting things here? You guys follow what I mean with this? So keep this in mind. I'm going to scroll back here for just a second, okay? So for every 1 picometer, I have 10 to the minus 12 meters. You guys catch what I'm doing now? You see how this is the same thing, right? Do I care which way you guys do this? No, I just don't like negative, so I usually do the one on top there, right? That's my very scientific way of doing things, okay? I don't like to have to hit an extra button on my calculator. Doesn't matter which way you guys do it? No, right? So here's what I mean. Let's convert, okay? Or, oh, sorry, I want to do one more quick spiel for you guys here, right? So, for every 1 meter, we have how many centimeters? What's our conversion between meters and centimeters? For every 1 meter, it takes how many centimeters? 100. Got it? Okay. 1 centimeter is equal to what? 10 to the minus 2 meters. You guys with me on this one? Everybody good? Feel comfortable? Okay. Do I expect you guys to be able to do these conversions on the first quiz and exam, all that kind of stuff? Yes. Okay. So now would be the time to get comfortable with that. I believe I have a link for you guys in the modules there that takes you to a website where you guys can practice this to your heart's content. What else would be a good source to find some practice for this? Begins with a B, ends with a ook, right? The B ook, okay? The thing that you guys spent money on, right? That would be a good source. Or remember, you can just go online and type dimensional analysis practice, and you'll find 10 million websites where you guys can do this. Sound good? Or if you don't want to do any of that, what else can you do? Come see me in my office, and I'll type it into Google for you. That's the way that you save time, right? You guys with me though? You have to get comfortable doing this. There's no way around it. I don't like to joke around with you guys a lot, and sometimes I come across as I'm not so serious, right? The class is already serious enough, is my view, right? But you have to be comfortable doing these conversions, right? That's all I'm trying to get you to think about. All right, so let's get this set up. Let's convert centimeters into picometers here real quick, okay? 1.90 centimeters. I'm going to convert centimeters, okay, into meters. Good. I'm going to take centimeters into meters, meters into picometers. Okay? I'm going to do this in 2 steps. Can you guys do it in 1? If you feel comfortable doing it, okay? Everyone all right with that? Now, I'm not going to write anything down, so give me just a second here, right? Excuse me, I'm not going to write down any numbers. I should have been clear about that. In my first step, I'm converting centimeters into meters. In my second step, I am now going to convert meters into picometers. Got it? Why am I doing this without showing you guys any numbers? What's the most important thing you guys can start to pay attention to? The units. Got it? If your units cancel out, let's see here. Centimeters going to cancel with centimeters, meters with meters. I wanted my answer in picometers. Everything looks good. Okay? I did the hard part. The hard part was just making sure I set up the math properly. Okay? You guys following along with this? Now I just got to fill in my conversion factors here, right? How can I convert between all these different things? Well, now I just look at my information or look into my brain, whichever way you want, right? There's 100 centimeters for every 1 meter, okay? For every 1 meter, I have 10 to the 12th picometers. Good? Everybody feel comfortable with that? All right, so somebody do that math for me. What do we have? What is my answer? What's your name? Sophia, what's the answer for this one? You got it? Didn't do the math quite yet? Who can help Sophia out here? What do we got? Yeah.
1.9 times 10 to the 10th.
1.9 times 10 to the 10th. Okay, and what's your name?
Caroline.
Sophia and Caroline. I remember a maximum 2 names per day. I might forget it by next time, but I'll try, okay? Everyone should just wear name tags. That should be required, right? Big old name tags. Everybody with me on the math? Everybody follow along with this? Everybody comfortable with this? Okay. Let's think about this for just a second then, okay? Now we have picometers, okay? But our answer was not just figure out things in picometers, was it? What did we need to figure out? How many atoms in a diameter of a penny, right? So what is this? What does this number mean right now to us? That's the diameter, right? That's the diameter of a penny in picometers. Good. Why am I stopping to point this out to you guys? Because right now it's just a number. What does that number mean to you? Remember just a couple minutes ago I said, hey, you got to think about what these numbers mean. I know you guys can set up the math, or at least we can keep practicing until we feel comfortable with it. But understanding what the number means and what it tells us, that's going to be important. Okay? That's a key step. So now we have the diameter of a penny, and we have the relationship of a diameter of a penny, right, to a copper atom diameter, right? Good. So now we need to relate diameter of a penny with the copper atom here. Let's get this set up. Let's think about this for just a second. So I'm going to take my 1.9 times 10 to the 10th picometers. Okay? And I need to get this into, let me pick a different color here just so we're not overlapping everything. So I need to get this into atoms. You guys with me? How many copper atoms? Right? Do I have a value that relates diameter to atoms in my units? You guys following the question that I'm asking? Do I have some information that's given that I can relate diameters or distances to atoms? Yes, right? Because what am I saying right here? The diameter of an atom is 256, right? Picometers. You guys catching what I'm saying with this? So what's my let me write down my units. I'm getting ahead of myself, apologies. Right? So I need to get rid of picometers and put it into atoms. Now the question becomes, do I have a conversion factor where I can relate this? Right? For every one atom, right, it's 256 picometers. Good. Everybody see how I got that information? This is the tricky part because it's kind of hidden in the question, right? It says and a copper atom has a diameter of 256. So really our units are not just 256 picometers, it's 256 picometers for every one atom. Everybody catching that? If you're lost, that's okay. What I want you to do is think about it a little bit over the weekend here, okay? Or come see me even better. That would be the best thing to do. Just like, I have no idea what you were talking about there, Dr. Rich. All right, come talk to me. We can walk through this. I'll show you guys what I mean. Okay? All right. And if I did this, I got something 7.42 times 10 to the 7th atoms, right? Somewhere around there. Yeah.
So we got like the same thing, but we didn't do the beginning part where we went from like centimeters to meters to picometers.
Mm-hmm.
We just did like this.
You did directly in one step.
Is that fine?
Yep, that's perfectly fine. If you, I'm sorry, what was your name?
Frankie.
Frankie?
Yeah.
Frankie, if you just multiply these together, you'll get the conversion factor that you used there.
Okay.
This was the 1 versus 2 steps that I was talking about there. Okay? Everybody following me on this? This is a tricky one, all right? Not as easy as some of the other ones we did. Okay? Question: does our answer make sense? Does our answer make sense? So let's think for just a second here. 7.42 times 10 to the 7th. Is that a big number or a small number? It's 742, right? With 5 zeros behind it. Is that a big number? Yeah. That means we have a lot of atoms, right? Does that answer make sense? Should we have a lot of really small atoms across the diameter of a penny? Sure. What if you got an answer where it was really small? Would that make sense? No, right? I promise. I'm not going to ask you any questions in here like the famous watermelon questions in a math class, right? Somebody wants to fit 42 watermelons into a car, right? You have to calculate volume or something, right? The questions that I'm going to ask you are actually based on reality. So you can actually look at your answer at the end and say, okay, this makes sense. It should be a big number. It should be a small number. But what's the key to answering that important question? We have to understand, right? We have to understand the things of what do these numbers tell us. And that's the tricky part of what I'm going to be teaching as we go through this semester, okay? Fair? All right. Let's see. I think we got one easy one to finish then. Or easier. I'm losing my voice at the end of the first week of class here. I'm not used to yelling it much over the summer, right? All right. So the question here, how many liters is 586 grams of water? See what you guys can come up with for this. How many liters is that much water?
Are we doing both?
We'll just do the top one for now. I mean, yeah. I mean, it's good for you to do both if you're just, if you've already finished the first one, you can do the second one. Aha. Right, so what I would start with is what are the units I'm trying to get at? How they can be related. What unit, what value do we need to relate the mass? Aha. You know the density of water. Yeah, those are the two things. I just want to write down.
So you do the top one and top one, so like you can't look at it.
I mean, sort of, right, because you're dividing by 100 here basically, so you're just moving that over by 3. So, yeah. I mean, so you can kind of eyeball it to get that idea from it, but that's just, I just wanted to like that. Talk to me about your math.
So we said that there's 586 grams. If 1 liter has 1,000 grams.
Where did you get that information from? Well, I'm not disagreeing with that, but what did you talk about class with respect to that? So let me back up for just a second. So, there, right? So remember, right now, now, you guys have to do the right math, right? I mean, I'm not disagreeing with you, but the point is, always think about where you got that information from. I promise, I'm not gonna give you guys something on that, like, you haven't seen this class, right? Yeah, that's fine, I was just asking, like, what in the world does this mean to you, right? So you're not wrong, because 1 gram per milliliter is equal to 1,000 grams per liter. Right, if you walk through that. Okay, cool. Where'd you get that number from? How did that work? I know, but I'm asking you, because you can't look that up, but like, like during the exam, let me just see if it's right here, right? saying you're wrong at all, but the point is the same thing I was talking about over there. Like, so remember, I'm going to tell you now, like, I will not give you a question that we haven't talked about this was in the class before. Right, so this conversion is something that just talked about. Right, so if you think about at the beginning towards this classic unit of data, what does it mean to the different results? That's exactly right, because if you're giving you mass, right, and I want you to convert it to volume, to do that, you need to density. Exactly. Now, it just so happens, right, if you convert 1 gram per milliliter into liters per gram, it's 1,000, right? So that's where Google's getting that information from. So it's not wrong. I'm just saying, think about where the information is coming from and what it means for the and what we're talking about. That's all I'm trying to do. But you guys, let's talk about this. Okay? Cool. All right. So I give you information about the mass of something, right? Grams is a measurement of mass. I'm asking you to convert it to liters. Liters is a unit of volume. How do I relate mass and volume? What piece of information, which we talked about, gives us the relationship between mass and volume? It's density. Got it? Now we're talking about water. Do I expect you guys to know the density of water? Yes, right? So anytime I'm going to have you guys convert mass and volume, which you'll be doing a lot in chapter 4, okay? You guys need to know the density or have some relationship between those two. Okay, so mass and volume and density are linked together. So what I'm going to do, I'm going to start in grams, okay? I'm going to convert grams into milliliters. There's my density, right? But I don't need my answer in milliliters. What do I need it in? Liters. What's my relationship between milliliters and liters? All right, so milliliters at the bottom and liters up at the top there, right? So just following the units, is everything going to cancel out if I do that? Now I just have to fill in the numbers. Got it? So I started out with 586 here. 586. Here is my, right, this is my density of water, right? And this is my, we'll just call it the dimensional analysis, right? Or it's not, well, that's fine for what it is, right? How we're converting our different metric units there, okay? So density of water, for every 1 gram, I have 1 milliliter, okay? Good? For every 1,000 milliliters, I have 1 liter. Fair? Okay. Then all you got to do is plug that into your calculator, right? Good? So essentially, what do we end up doing? Just taking 586 dividing by 1,000, though, right? That's all the math comes out to be. But do you understand the math that goes behind it? That's always the point that I'm going to keep trying to point you guys towards. Okay? So we do this, right? 0.586 liters. Okay? Oops, sorry, I messed up my colors there. Okay. Good. All right, the question at the bottom, I'll let you guys kind of work through that on your own there. It's the relationship between milliliters and cubic centimeters. What's the relationship between a milliliter and a cubic centimeter? For every 1 cubic centimeter I have 1 milliliter. Can you guys do that math in your head?
Yep.
Okay. I heard one person say it, the rest of you guys, uh-oh. You guys with me on this now? So, do I expect you guys to write down the math if you're just dividing things by 1 to change units? Absolutely. Yes, I do. Why? Why am I going to be such a stickler about this stuff? Is it because I'm a jerk? No. Is it because I want you guys to use up ink? No. It's because when you guys make a mistake, you have to look back and see it where it happened, okay? It's not just for my enjoyment, okay? It's for you guys to say, oh, wait a minute, this number doesn't make sense. Where did I switch my units along the way? What part of my work was incorrect? So even if you guys are just multiplying or dividing by 1 to change units, show me that. Write it out, okay? Sound good? All right. I think that's the end, right? Oh no, I've got one more problem here for everyone. Ooh, another tricky one to end the day. Uh-oh. This one's tough. Now, you can go into Google and just get this answer instantly. Okay? Try and avoid that. See if you guys can come up with this on your own for the moment, okay? Think about the units, right? Think about the units. My favorite part of my job is when I get to loom over you guys and make you nervous. Okay? Be careful. This is the tricky part of this problem. There's not 100 cubic centimeters in 1 cubic meter. There's 100 centimeters in a meter. Got it? You get what you need to do there? So I have a thought for everyone. I have a thought for everyone. How many cubic centimeters are there in a cubic meter? Is it 100? No. There's 100 centimeters in 1 meter. Right? But did I say there's 100 cubic centimeters in 1 cubic meter? How do we make a cubic meter? We take a cube that has 1, right? By 1, by 1. Length times width times height, right? Well, so we have a perfect cube that's a meter on each side. And if I multiply 1 times 1 times 1, I get a cubic meter. Is everybody following what I'm saying? Because I'm giving you a clue on how you solve this problem. There's 100 centimeters in a meter. But there's not 100 there's not 100 cubic centimeters in a cubic meter. Because you have 3 dimensions. You guys with me on this? So draw it out, right? Picture this in your mind. Here's what I'm getting you guys to do, right? Everyone draw their best cube. Ah, very nice and symmetric, right? This cube is 1 meter by 1 meter by 1 meter. Can you guys convert 1 meter into centimeters? Yeah, right? So can you convert this side into centimeters? Sure. Can you convert this side into centimeters? Can you convert this side into centimeters? You guys following what I'm doing here? If we're dealing with cubed or squared units, we're dealing with multiple dimensions. Okay? 1 meter times 1 meter times 1 meter. Right? 1 meter times 1 meter times 1 meter equals 1 cubic meter. Everybody following that one? That's what we're talking about, right? 100 centimeters times 100 centimeters equals what? 1 times 10 to the 6th, or 1,000,000 cubic centimeters. Everybody follow how I got this? Are we doing the same conversions we've been doing all along? Yep. All I'm asking you guys to do is what? 3 times. What if I go nuts on the exam and I say we have a 6-dimensional cube? How many times did you guys have to do it? Does that seem easy enough, right? See, isn't theoretical math easy? Do you guys know what a 4-dimensional cube is called, by the way? You guys heard of a tesseract before, right? You guys probably heard of one of the Avengers movies and one of those. That's actually a real thing. It's a 4-dimensional cube, right? Now, does it look like a cube as we imagine it? No. How many of you guys are taking physics though with Dr. Sadasovich? Anybody in here? Nobody? Good choice. No, I'm just kidding. No, I'm joking. Oh crap, I'm being recorded. Right? But Dr. Sadasovich is one of our physics faculty. He deals with theoretical physics in a lot of ways. And so they're dealing with these multi-dimensional shapes. Right? But who's heard of Salvador Dali before? Oh, you guys, right? The famous artist. He painted a tesseract actually in one of his paintings. Right? So it's one of the few kind of contemporary representations of a 4-dimensional thing. That's very, very, very cool stuff. And I got on a tangent here. Let me finish up real quick before I start rambling with you guys. All right, but this is the tricky thing to remember with cubed and squared units. It's not the same conversions as what you guys are remembering. It's not 100 cubic centimeters is 1 cubic meter. It's 3 of them. Okay? Good. Now we can finish this up because we can say 430 cubic centimeters, and I need to get my unit in cubic meters. So centimeters cubed on the bottom, cubic meters on the top, and I fill in my values here. For every 1 cubic meter, 10 to the 6th cubic centimeters. Good? Yeah. Oh, sorry, I thought you raised your hand there. I'm just pointing you out now in the middle of class. All right. All right. Good place to end for the day. No, you guys want more? No. All right, that seems like a good place to stop. I'll see you guys on Monday, okay? Yep. Yeah. You sent me an email, right? Was that you? Oh, okay, okay. Okay, cool. So yes, we're by on Monday or after 5. It'll be nice to meet you, man. Hey. Yeah, so I think on the syllabus for my office hours are like 1 to 2:30 or something. If you go up on there, but do this, send me an email and tell me when you're available. Any day except for, I can't do Tuesdays and Thursdays because I'm teaching basically all day is what it is. But if you send me an email saying, hey, Dr. H, here's my availability on Monday, Wednesday, Friday, I know we can find some time. Okay? Yeah. No, I know. Yeah. Sure. Okay. 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 Sure. Sounds good. Okay. Perfect. You guys have a busy semester. Yeah, but I like the idea there, right? We need to stay ahead of this. So do me a favor, whenever you get a couple minutes, just send me an email. Think about when you have some free time and we can set something up, okay? And what's your name? Jamari? Nice to meet you, Jamari. Uh-huh.
We need you to chapter one worksheet.
No, those are there as a, oops, I'm still recording. Now you're gonna be world famous, right? Everyone's seeing you ask a question
It
there,
actually
right?
popped up on my YouTube.